Now in section 3.2, we look at multiplication, division, and the order of operations. So just like we did with addition and subtraction, we give them a problem in context and we have them figure it out. And again, they'll do this well. So you have 40,000. You have to share it with your 3 siblings, so you divide by 4. Okay, you can read through the problem. I'm sorry, I know them by heart by now. Then you make 5 times your investment, and that means that you now have $50,000. Okay, so writing this horizontally is 40,000 divided by 4 times 5. Okay, and then you could have them, so we know from here that we did this from left to right. We did the division first. What if you did the multiplication first? You would get a different answer. So you divide by the 40,000 divided by 20, and you could talk about what that would mean in the context of the problem. Well, that would mean you're sharing the $40,000 and you're dividing it into 20 equal pieces. So it's like you now have 19 siblings. Instead of this, which means you shared it with 4 people, then you made 5 times the amount. Okay. So again, in this idea of a string of operations, have them test that they come out differently. And again, it's always good to show them a problem. And there's plenty in the practice problems where even if they do the correct order or the incorrect order, they get a correct answer. So they could see that they should always follow this general order of operations, even though sometimes they'll get a correct answer if they don't. Okay, so there's our rule 2. And then we move on to looking at all 4 operations together. Okay, again, here's an example where, look at this real quickly. Bill went to the store, bought 3 6-packs and an additional 2 cans. So that's 3 copies of 6 plus 2 more cans. Okay. And then on this one, he bought 3 6-packs of cola and an additional 2 6-packs of Diet Cola. So that's 3 6-packs and plus 2 more 6-packs. Okay. So there they are written horizontally. And you want to talk about, well, which operations do you first, which makes sense here. Okay, so again, if they do these as separate operations, they would do 3 times 6. Find the result, add 2. Here, they might add the 3 and 2 and say there's 5 6-packs, so they'll do addition first. So we'll do 6 times 3 plus 2, and then multiply. Okay. We haven't officially gotten to parentheses yet, but you could say, oh, yeah, we'd put this in parentheses to show that we're going to add first when usually we multiply first. Or they do the multiplication separately and then add the results. Okay, so again, just showing them how, comparing and contrasting these 2 types of problems and showing how and why we do the operations in the order we do and we represent them symbolically. Okay, so that's the 3rd rule, and then some more practice. 3.5. Oh, I skipped parentheses. 3.4, parentheses as a tool for changing order. So kind of this idea from the last one where you put it in parentheses. Okay. Here, Howard bought a $25 comic book and a belt buckle. He paid with $100. How much change does he receive? Again, they may do this by adding these 2 and then subtracting it, or they may take the 100 and subtract each one. When they write it as a string of operations, okay, but they need to know that if they're going to put it, wrong, not addition, if they're going to put subtraction here, the 25 plus 35 need to be in parentheses. So they might put subtraction, but not put, they might subtract the 35, okay, because they think that this subtraction only applies to one term. Okay, so using parentheses to say, well, I'm going to add up how much I owe and then subtract it. Okay, so again, build those all up. So now we have all the operations. We have parentheses, and here we introduce exponents in 3.5. This is a good activity to have them do. This is in the media lesson packet, but all you really need is they can just draw a rectangle. Okay. And developing the idea of exponents. So he's going to cut this cake into 2 pieces. Okay. You might want to have them keep track of how many pieces. Cut all of those in 2 pieces. Now we have 4. Cut all of the 4 pieces in 2 pieces. We have 8. Cut the 8 pieces into 2 pieces. Now we have 16. And then cut the 16 into 2 pieces, and now we have 32. Okay. And you can have them look for patterns. 2 plus 2 is 4. 4 plus 4 is 8. Okay. But how are we going to represent this symbolically? Okay. So we had the 2, and then we multiplied by 2 to get 4, and there's this temptation to add add another 2 pieces, 2 plus 2 instead of 2 times 2. They can go that route, but I think they'll see that it's going to make it more complicated in the end. So take the 2, multiply by 2, and we'll have 5 factors of 2. And we're going to actually use that factors of language. And then someone said, this is really annoying to write, so let's make a shorthand, which we call exponents, and this is 2 to the 5th. So we have some terminology here. We want them to see that multiplication is repeated addition. Exponents are repeated multiplication, which is why we say factors. So you know that lots of times they like to multiply the 2 times the 5 and get 10. Remind them that would be 5 times 2. Okay, this is repeated multiplication. Okay. They need to use the correct words here. I'm sure you've heard them say, especially in algebra, they'll say x2, okay, when they mean x squared or x to the 2nd power. So we wanted them to develop good language first, because if they're saying x2 in their head or out loud, they might not understand what you mean, and they're not connecting their idea of what x squared or 3 squared is to what your language is. Now we have these examples where we have them write expanded form, word name, factor language, and math equation. Okay, so basically, expanded form is writing it out as a product. Okay, so 6 times 6. Okay, word name, we'd say 6 squared, or 6 to the 2nd power. Factors of, or factor language, 2 factors of 6. And by math equation, we mean that we want to write this 6 squared and what is it equal to. So this is an identity equation, but it is an equation. Okay. Here, when the negative sign is not in the parentheses, we're going to think of it not as a negative, but an opposite. Okay, so I'm not going to write these all out, but so this will say the opposite of 6 squared. In expanded form, we'll have negative 6 times, or the opposite of 6 times 6. Okay, for factor language, the opposite of 2 factors of 6. Whereas here we'd say negative 6 squared, which is 2 factors of negative 6. Which we'd write like this. That's how they enter it in Math AS. So we want them to start to distinguish between all these different types. I'm sure you've seen them have problems with these before, and whether they're squaring the negative or not. You can talk about how negative, or the opposite of 6 squared, can be seen as negative 1 times 6 squared. Officially, we haven't, since we're just introducing exponents, we haven't said that you do exponents before multiplication. So that may not quite make sense here, but I think using the word opposite is really what helps them distinguish between the opposite of 6 squared as opposed to negative 6 squared. as this outer operation that we perform last. Okay, let's start a new video.